One way to test whether some formulas tautologically entail another is by using a truth table. Let's work through two examples. First, consider the claim that the premises P or Q and not P and Q tautologically entail the disjunction P and not Q or Q and not P. By definition, that entailment holds just in case there's no valuation of the atoms involved in those formulas, which makes the premises all true and the conclusion false. To tell whether there is such a valuation, we just write down all the possible valuations of the relevant atoms and then work through them one by one to see if any of them make all of the premises true and the conclusion false. So first, what are the relevant atoms? Well, there are two atoms that occur in the first premise, namely P and Q, and neither the second premise nor the conclusion has any atoms beyond those. So the only relevant atoms are P and Q. So it's all possible valuations of those two atoms that we need to look at. So let's write those down. Now we need to check whether any of those valuations of P and Q make both of the premises true and the conclusion false. So let's add to our table a column for the first premise, a column for the second premise, and then a column for the conclusion. Do any of the four possible valuations of P and Q make both premises true and the conclusion false? We could start with the first row of the table, compute the truth value for both premises on that line, then compute the truth value for the conclusion on that line, see if we get both premises true and the conclusion false. If so, then we could stop right there, because that by itself would show that the claimed entailment does not hold. If we don't get both premises true and the conclusion false on that first line, we could then move on to the next row in the table and repeat the process. That process will definitely give you the answer. It's not necessarily the most efficient way to do things, though. Typically, a better way is to look at your premises and your conclusion and see which formula is the simplest. In this case, it's the first premise, P or Q. So I'll just fill out the whole column for that formula first. Notice that the premise P or Q is false on the last line. So we can already conclude that that line of the table cannot be a bad line. That is, it can't be a line where both premises are true and the conclusion is false simply because the first premise is not true on that line. Since we already know that the last line is not a bad line, we can just ignore that line from this point forward. The next simplest formula is the second premise, not P and Q. The conjunction P and Q is true on the first line and false on the second and third, so the negation of P and Q is false on the first line and true on the second and third. We don't have to worry about its truth value on the fourth line because we already know that can't be a bad line. Now, since the second premise is false on the first line, we can conclude that the first line can't be a bad line either. It also won't make both premises true and the conclusion false. So we can ignore that line too from this point forward. Finally, we move on to the conclusion. It's a more complicated formula, but luckily we only have to evaluate it on the second and third lines of the table. Let's start with the second line. On that line, Q is false, so not Q is true. So since P is also true on the second line, the conjunction P and not Q is true, and thus the whole disjunction P and not Q or Q and not P has to be true on this line because the first disjunct is true. So on the second line, both premises are true, and so is the conclusion. So this also is not a bad line. The last line to investigate is the third line of the table. On this line, Q is true, so not Q is false. So the conjunction P and not Q is false. So to determine the truth value of the whole disjunction, we need to compute the truth value of the second disjunct, Q and not P. On this line, P is false, so not P is true. So since Q is true on this line, the conjunction Q and not P is true, so the whole disjunction P and not Q or Q and not P is true. So on the third line, once again, both premises are true, and so is the conclusion, so this is not a bad line either. None of the possible valuations of P and Q made all of the premises true and the conclusion false, so the claimed entailment does hold. Next, let's consider the claim that the premises not P or Q and not Q and not R tautologically entail P or R. This time, if we look at all of our premises in our conclusion, we see three different atoms involved in those formulas, P, Q, and R. So we need to look at all possible valuations of those three atoms. Let's write those down. Let's also make a column for each of our premises and for the conclusion. This time, the simplest formula is the conclusion, so let's fill out its column first. The first disjunct P is true in each of the first four rows, so P or R is true on each of the first four lines. R is true on the fifth line, so P or R is true on that line too. On the sixth line, both disjuncts are false, and we find that on the last line too. So P or R is false on those lines, but since R is true on line 7, P or R is true on that line as well. Now notice that there are only two lines on which the conclusion is false. On all the other lines, the conclusion is true. But any line where the conclusion is true can't be a bad line. It can't be a line where the premises are true and the conclusion is false. So from this point forward, we can ignore all 6 lines where the conclusion is true and just focus on the 2 lines where it's false, since those are the only possible bad lines remaining. So let's next look at the first premise, which is the simpler of the two. Q is true on line 6, so the premise not P or Q has to be true on that line as well. What about line 8? P is false on that line, so not P is true on that line, so the premise not P or Q is true on line 8 as well. Since the first premise is true on both line 6 and line 8, both are still in play as potential bad lines. Both could still be lines where all of the premises are true and the conclusion is false. So next we need to look at the second premise, not Q and not R, on both lines. On line 6, Q is true and R is false, which makes not R true. So the conjunction Q and not R is true, so its negation is false. Since the second premise is false on this line, it can't be a bad line. Now let's figure out the truth value of the second premise on line 8. On that line, Q is false, so the conjunction of Q and not R has to be false, so the negation of that conjunction is true. So on the last line, both premises are true and the conclusion is false. Thus, there is a valuation of the atoms P, Q, and R, which makes the premises true and the conclusion false. So in this case, the claimed entailment does not hold.